Alright, so now we are going to talk about booleans, the boolean type, and some conditional operators in logic. Let's get into it. First thing to know is that booleans cannot be converted into any other type, not even explicitly. So they're sort of just out there doing their thing. But booleans are more than just a type. They are a way to represent true and false, but you can also use them for logical operators on any type. So I will show this really quickly. We already did a little bit of this, but we can see if we do a console.writeLine, and then basically what this is saying is x equal to y? We're not assigning it equal to it, we're asking if it is. So using this operator will return a Boolean value. So really quickly, let's go have a read key. So that way it pauses our console, and we'll start this up, and it prints out false. And this is actually a Boolean that it returns. So what that means is we could also do this. Say bool result, and we test whether x is equal to y, and then we can put result in this console output, do the same thing, and then says false. So that's just a way to prove that this x equals y is actually a Boolean, and we can actually assign that to a Boolean variable, although it's much more likely that you do this within an if statement or a while loop or a for loop, just anything that you want conditional statements. So I'm just going to quickly list off all of these conditional operators that there are. There's this that's checking if something is equal to the other object. This is seeing if it's not equal to the object. This is your greater than, less than or equal to, and then greater than or equal to. That is all the logical comparison operators that there are. So quickly I'll just show, this is just saying x is not equal to y, and since it's not equal to y, it's true. So we expect that to be the result when we print it out, and yep, that is what we see. And the nice thing is you can actually chain these together. So let's go ahead and stop assigning this to a Boolean and just do an if statement. So I'll say if x equals y, and I'm going to add another int in here, z, and we're going to change z to be equal to x. So we're going to do an x equals z. Dot right line, x, y, and z. Let's go ahead and print this, and nothing prints out. The reason that this happens is because this logical operator is saying, is x equal to y? So does x equal y? Which it doesn't. And it actually stops there, because with these two ampersands, it's basically saying, this one has to be true first, and then we check this one. But since this first one is false, it knows that not both of them are true, so it stops looking and doesn't go into this if statement. But if we were to do x does not equal y, and then x equals z, let's do equals z and doesn't equal y. So now we expect this to print it out, and it does. And the reason it does is because first it checks, is x not equal to y, which it isn't. So that is true. And is x equal to z, which it is. So both halves of this logical operation are met, and it goes into this if statement. There's also this other operator called OR. And so OR means that only one of these two comparisons, or both, has to be true in order for it to go into this if statement. So again, if we were to run this, you can see that it runs it, right? Because both of these are true. So what it actually does is it goes in and checks, is x not equal to y, which it isn't. So that's true. It doesn't even check this comparison because it already knows that the operation has been met and that this entire statement will operate into true. But if we change this back to equals equals and we go back in, it still prints it out. Because while x is not equal to y and this is false, this half is true. So only one out of these two, or both, has to be true, and it goes in, prints that out. And I showed this in a previous episode, but you can actually use bools very nicely with if statements. So if I just type in is true into here, it's saying is true true, which it is. So it's actually going to go in to this if statement. So if we run this, it goes in and says is true is true. So all it is checking is, does this evaluate to true? And since this bool is true, then it does. If we want to see if is true is not true with this exclamation point, it's basically the exclamation point flips it. So it's saying is true not true. But that's not the case. Is true is true. So it actually doesn't go into this if statement. But if we were to change this to false and run it again, it does go into this because is true is false, and that's what we're making sure of. And finally, there's one last thing that I want to show. There's something called a ternary operator. So we'll just use this with another function really quick. So if we want to create a function that returns the maximum number, what we're going to do is say if a is greater than b, then return a, but if not, return b. So it does the logical evaluation, checks is a larger than b. If it is, then it's going to go to this first case here. And this first case is to return a because it's larger. Otherwise, this evaluates to false, meaning that b is either equal to or greater than a, and it's going to return b. So that's the ternary operator. It's just a shorthand way of writing this if statement, basically. So you can basically say, is a bigger than b? If it is, then return a. Else, return b. So obviously, this one line is a lot shorter, and it just looks a lot better. But this is the more verbose way, and just a way to help visualize what is actually going on. So that's Boolean operators. Thanks for watching.